Alright, let's look at the homework 9.4, problem number 1. Alright, so let's look at this logistic equation. Alright, so we want to find the carrying capacity and the value of K. So I'm going to rewrite a little bit. Alright, so first I'm going to pull out 0.04 from both terms. So you're going to have just P minus, let's see, 0.04 there, two more zeros, right? So it's going to be 0.0, 0.01 P squared, right? And we can actually pull out P too, so it's going to be 0.04 P. Then you have a 1 minus, right? 0.01 is 1 over 100, and the P is pulled out, so you're going to have P over 100, right? So if you want to find the carrying capacity M, which shows up right here, right? So it's 100 right there, right? And the K shows up right here, right? So K is 0.04. Alright, let's type it in. So we found the carrying capacity to be 100 and the value of K to be 0.04. Right, so let's check the answer. Submit for testing. Alright, I came back and looks like we got the part A correctly. Alright, so let's look at part B. So we have this direction field given. And let's see, what are the slopes close to 0? You can see that equilibrium solution is at 0 and 100. That's where the derivative equals to 0. So P is equal to 0 and P equals 100. Right? Where are they? They meaning the slopes, the largest. Right? So since you can see that dp over dt is a quadratic function in P with the negative leading coefficient. So it's the largest at the vertex, which is between, let's say, right in the middle between 0 and 100, which is 50. So 50 would be the answer for that. All right. Which solutions are increasing, right? So you can see that it's going to be, right? So if you factor this out, right, looks at this guy, factored out version, right? And remember that the this is a facing down parabola, right? So you know, the ballpark picture is this. Right, since equilibrium solution is at 0 and 100, right? So between 0 and 100, the derivative is going to be positive. So you can see that it's increasing between 0 and 100. And solutions are decreasing, so that's after 100. So here 100, and maybe I have to get the symbol there, infinity. Alright, so let's check the answer. Alright, submit for testing. Alright, I came back and looks like we got all parts of part B correctly. Alright, part C. Use the direction field to sketch the solution for initial population of 20, 40, 60, 80, 120, and 140. Right? So let's do that with GeoGebra. Alright, let's sketch the slope field first. Slope field. Alright. And the equation is 0.04 times P times 1 minus P over 100. Right, let's hit enter. Alright, so let's click here. Click here. If I can click it. Alright, hold on. I cannot click this. Hold on a sec. Alright, okay, so the problem was I was using P, so I have to use a slope field. Alright, so we have 0.04 y 1 minus y over 100 and hit enter, and then alright, now we can see the slope field. Alright, then what we need to do is I need to be able to see, let's say I have to rescale this so that I can see at least 100, right? So here and like that, and then maybe let's see, maybe go like this. Alright, now we can see it. Alright, so let's write down the solution. So I'm gonna do solve ODE. Alright, then equation is going to be y prime is equal to 0.04 y times 1 minus y over 100. Then solution is, let's see, I need to put, let's see, a point, we have to put the points here. Alright, the points is going to be, the first one is, let's see, 0, 20, right? And click enter, right? So this is a solution curve with 20, right? And then we basically do this same thing here, right? And I'm going to copy this, right? Then I'm going to just enter here. Right, actually we don't need this part. Right, then 40. Right, so change that to 40. And this is going to be the curve. Alright, and I'm gonna just do the same thing. Alright, and oops, I'm gonna just copy that and put it in here. Alright, and the 60, enter. Oh, actually this is not good. I messed that up here. Alright, this is E right there. Alright. Alright, so this is going to be with the, let's see, that was 60, right? Let's see, maybe I didn't change it, sorry. 60. Alright, we got that. Alright, then we're going to just, here, and just keep on doing it. Let's do, alright, so here, alright, 80, right, and we have another one, right, then we have 120, right, then we have solution here, and one more, 140. Alright, so 140. Alright, then C. Alright, so those are the solution curves. Alright, so keep those pictures in mind, and then let's answer these solutions. Alright, all of these solutions approach P equals 100 as T increases. Okay, also all the solutions are increasing, right? That's not the case. Look, you can see that some of them are actually decreasing. So that's the first one. All the solution approaches P equals 100 as T. All solutions are decreasing. That's not true. all the solutions have an inflection point. Let's see, that's quite not true here. There's no inflection point. Here, there's a change in concavity. These guys have inflection point, so that's not true. None of these solutions have inflection points, so that's not true. So it's got to be this one. All of the solutions approach p equals 100 as t increases, and the solution differ since for p0 is between 0 and 100, they're increasing. For p0 is greater than 100, they're decreasing. Looks like it, right? Decreasing here, increasing here. Right, so this is the choice. Which solution have the inflection point, right? So you can see that the inflection point seems to be, right, this one has it, and this one has it, and this one has it, and also this one seems to have it. It's over here. So, and let's see, 20, 40, 60, 80. Seems like this is the solution, right? Because all of these guys are less than 100. All right, so let's double check. All right, submit for testing. All right, actually, I messed up this one. Looks like, let's see, inflection point is just 20 and 40. Maybe look at it. Alright, so 20 and 40 you have that, but inflection for 60 and 80 is actually before t equals 0, so we can't really have a negative time, so not including 60 and 80, so only 20 and 40. Alright, so this has got to be it. Oh, actually, so this has to be checked. Alright, so let's double check again. Alright, submit for testing. Alright, it came back and looks like we got part C correctly. Alright, let's look at the part D. What are the equilibrium solutions? We already know it's a 0 and 100. And how are the solutions related to these solutions? Alright, so it looks like let's see, move away. So increasing solution move away from p equals 0, and all non-zero solutions approach p equals 100. Right? So let's check the answer and submit for testing. Alright, it came back and looks like we got part D correctly. Alright, that's it. I hope that this was clear.